Yeah. No, because we're learning. All right, so we're going to jump into chapter 9, which is on
why is it so loud in here? I can't really hear it. Simmer, people, simmer.
hello, hello.
Oh, this isn't the right one.
Okay, so chapter 9, we're really going to focus in on one particular type of function. Remember we talked about linear ones and quadratic ones and cubic ones, and we did that whole thing where we had to name them and how many terms and things like that. Of all of those that we talked about, probably the quadratic ones are the most important. The linear ones might be a little bit more important than that, but quadratic ones are super, super important. And the reason for that is that the shape of a quadratic equation or function is what's called a parabola.
It looks like a rainbow.
It looks like a rainbow. It's a double rainbow all the way across the sky.
It looks like that one mark at that one place. What are you?
The cool thing about this shape right here is that when you throw something through the air, it comes back down in this
I hope it comes back down.
shape path like that. And so these are, but even if it goes straight up,
It still comes down a little bit curvy.
yeah, it comes down a little bit curvy and you still get a little bit of a parabola thing out of that, okay? That's a good point. And
Ow.
to truly study the things, then you'd have to take into account things like wind and friction and stuff like that. But that gets more complicated than we're ready for. Okay, so we're going to just simplify it a little bit. But I just want to give you a sense of why these things are important. Okay, so the very first section in the chapter is on these graphs. All right. So like we talked about in the last chapter, a quadratic function looks like this. Okay? So this is the general form of a quadratic function. And we've already talked about in this class the general form of a different kind of function, which I'm sure you will all remember. Y equals mx plus b. Remember those?
Yeah.
Okay. And in this case, the m was the slope, and the b was the y-intercept. And so we talked about those quite a bit. We graphed them and solved them and things like that. We're going to basically do the same thing with these functions right here, but now because you are a little bit older and a little bit smarter, you can see that these are a little bit more complicated than these over here, because instead of just having two terms like this one, these have three terms, okay? And it's got an x squared in there, which makes things quite a bit more complicated, all right? So, like I said, if you look at the graph of these, let's get a graph of one of these going.
Does that mean we have graph paper to use?
We're going to be doing some graphing, yeah? Okay, so if I looked at a graph of these, it would have this general shape like that. And like I said, that's called a parabola. Okay? A parabola has some exciting features. For example, what do you notice is true about this parabola? It's upside down, okay? And so since this is upside down, that means that this point right here is the smallest point on the graph, and that is called the minimum. Okay? Not all parabolas are upside down, like I showed you the one at the beginning of the class. Some of them go right side up. And now this point right here would be the maximum. Okay? So depending on which way the parabola goes, and instead of saying upside down or right side up, what we're going to talk about here is that this one right here opens up. Can you see that page?
No.
Really should be paying attention here. Beginning of the chapter is the most important section, laying the foundation of everything we're going to
I have a
learn.
question.
Okay, hold on just a sec. So this thing right here is called opens up. If it opens up, it makes a cup. Right?
Or a U.
Okay, this one right here opens
That's a cage.
down. And if it opens down, it makes a frown. Okay, so you can remember that. Opens up, makes a cup. Opens down, makes a frown. Okay, so if it opens up, then this. If it opens up, then this point right here is called the minimum of the graph. If it opens down, then this point is called the maximum. Okay, and then Nolan said that both of these have a special word. They're both called the vertex of the graph. Okay, so whether it's the minimum or the maximum, that point right there is called the vertex of the graph. Wondering why so few of you are writing this down. Do you really think that you're going to remember this?
Absolutely not.
Seems highly unlikely that you'll be able to remember this 2 weeks from now when we have a test.
You want to make a bed?
Okay, you can get some. Someone will give you some.
You want to make a bed?
I said highly unlikely. I didn't say not possible. Yeah, no, I know. But so what would I bet you? That it's unlikely and then you remember, and that doesn't mean you proved me wrong. It's just chances are you're not. Okay? So the vertex is that point right there that's either the high point or the low point of the graph. It's right in the middle of the graph. Okay? And then depending on whether the graph opens up or opens down, that's either going to be the maximum point of the graph or the minimum. Yeah. Ah, good question. We'll talk about that in a second.
Do you have 2 of these ones? I don't know. Do you have 2 of those ones now? Or do you have 2 of the smiling face? I don't feel good.
All right, so opens up, opens down. Now, Lexi asked a very good question. She said, do they ever open sideways like that? Okay, I took you to mean something like that, okay? And the answer is no. And this would be like the billion-dollar question if anybody could tell me why they don't go like this. Right, because this would not be a function because a vertical line will cross 2 points on that graph. Okay, so if they open sideways, they fail the vertical line test. And so those are not parabolas that we're going to mess with. Okay? All right, one more feature of the graph. Guys? Guys? No, you're good. It's these Nolan and Graham that are just having a conversation when I'm trying to teach. One more exciting feature of these graphs is that you can draw a line, imaginary line, right down the middle of them. And what's true about yeah, you got it.
It's half.
Okay, the word he's looking for is symmetrical, yeah.
Yeah, I knew it. I got it.
I know.
Okay, if you draw a line right down the middle of those, what's on the left and right side of that dotted line will both be the same, okay? And so this imaginary dotted line is called the axis of symmetry. Okay? So, hopefully what you should understand so far about parabolas is that sometimes they open up and sometimes they open down. Okay? Which means sometimes they have a maximum point and sometimes they have a minimum point. That point, whether it's a maximum or a minimum, is called the vertex of the parabola. And then the imaginary line that divides the parabola in two equal pieces is called the axis of symmetry. Okay? All right, so let's mess with these a little bit. All right, so to start with, let's take this parabola right here. Okay, put that away, please. And will someone raise their hand and tell me the coordinates of the vertex of this parabola? Read.
The x comes first, right?
The x comes first, yep.
0, -1.
Nicely done. So this point right here, which is the vertex of that parabola, has coordinates 0, -1. Because like you said, the x comes first. We went nowhere in the x direction and we went down 1. Okay? Is that vertex in this case a maximum or a minimum? This would be a minimum. Okay? Nice deal. All right, let's try another one. Yo.
She forgot your name.
It's okay, it was a long break.
Not really.
No, I remember it. I was thinking about something else at the same time.
Sure, Paige, why not? Let's do a different one and make that a maximum. All right, same dealio. Somebody tell me the coordinates of the vertex of this parabola. Graham, what'd you say?
6, 9.
Okay, Graham went with 6, 9 because it's this point right here, and you have to go over 6 and up 9. Is that a maximum or a minimum, Nolan? This would be a maximum. All right, so we feeling good about that?
Yep.
Okay, let's take this general thing right here, and there's 3 pieces to it, right?
Right.
There's the ax squared, the bx, and the c. Let's just focus on some easy ones first, where it's just y equals ax squared, and see what those are going to look like, all right? So what I'm going to do
So we have to draw the graph and do it?
is I'm going to ask you to give me an equation for a parabola that only has an x squared in it, and we're going to mess around with a and see how that changes the way the parabola looks. So give me a number to
7.
start with. So 7.
Yeah.
If I graph 7x squared, boys,
Ladies.
then here's what the graph looks like. Okay, so there's my parabola, y equals 7x squared. Now let's change that number, okay, and see how that affects the parabola. So he says let's go with 14x squared. Okay, and how do you notice that my new one is different from the old one?
Because it's small.
It's smaller, it is, the minimum's the same. They're both opening up. How would you describe it? It's skinnier. Okay? So what do you think is true then about the number in front of the x squared and the skinniness of the parabola? The higher the number, the skinnier the parabola is Jason's guess. So let's change this to 24x squared. And if I do that, what's it going to look like?
Skinnier.
It's going to be even skinnier. So there's my original one. And then there's my new one that's super skinny inside the other one there. Okay? Say that again. Okay, so let's put another one in there. So Lexi says, what about 2x squared? What do you think this graph is going to look like?
Big.
It's going to be wider. So here's my first one.
No, it's
There's
not.
another one that's skinnier than that. And then there's 2x squared is even wider. So, okay.
It's like a fire.
All right, good question. Wow, Lord is freaking it.
If A is bigger than
Okay, so there's the first thing that we learned that you should write down. If A is bigger, then the parabola is skinnier. Okay? And then you can do the opposite would also be true. If A is smaller, then the parabola is going to be fatter or wider, right? Okay? So give me a really small number.
Wait, what's
Okay.
that last word say?
Let's
Skinny.
stay away from the negatives for right now. Tristan asked that. We'll mess with that in a second. But, okay, good. 0.2. So let me clear out some of this mess so it's not as cluttered. But yes, if I put in an even smaller number there, 0.2x squared, and then I graph that, there's 7x squared, there's 0.2x squared. So since the 0.2 is really small, even less than 1, that means that parabola is super wide. Okay? A perfect half circle is not actually a parabola. You can see that even though looks like it's getting more and more circular, to make it an actual circle, you have to mess with things a little bit. You'll get to that in 2 years.
2 years.
Okay?
What class is that?
Advanced algebra.
I'll be
All
there
right.
next year.
Tristan says, what about a negative number? Okay? So let's make this negative 0.2x squared. Does anybody have any guesses how that's going to affect the graph? It's going to go down. No, there it is right there. Pop that for you. So yes, if it's negative, then that's what makes the parabola go down. Okay? And that, Cheyenne, is easy to remember because, right, if A is positive, then that means you're positive, you're happy, you're smiling, right? So the parabola opens up. If A is negative, then you have a frown. Okay? So we're learning a lot of things about the graphs of the parabolas. Hopefully you guys are copying these down so you can look them up when you're doing your homework and learn a little bit. Okay? So if A is bigger, then the parabola is skinnier. If A is smaller, then that makes it wider. If A is positive, then that means the parabola is opening up, or like a smile. And if A is negative, then that means the parabola is opening down like a frown. Okay, I won't worry about it. All right, we're going to do one last thing today. And that is we're going to mess with the C. We're going to skip over the B because that really screws things up and makes things really complicated. But we're going to mess with the C here. What do you think happens if instead of going just plain old 7x squared, I go 7x squared plus 3?
OMG.
What do you think is going to happen?
It's gonna get.
It starts at 3, right? Because when we were doing y equals mx plus b, the b was our starting point on the, where did it, on the what? On the y-axis, yeah. So the same thing is true with parabolas. If I go 7x squared plus 3, you can see that now this is going to cross the y-axis at positive 3, right?
Yes.
So if I do the opposite with this one that's opening down, and instead of adding something on there, if I subtract something, so for example, if I go minus 5, what's that going to do to the graph?
Go down.
It's going to make it so that it goes down 5. Okay? So the moral of that story is, just like when we were graphing linear equations, the C tells me where it crosses the y-axis. Okay? And then, like I said, we'll mess with the B another time because that makes things very, very
C tells
tricky.
me.
But we will get there eventually.
What's up, guys?
I'm not gonna know how to do it.